Good morning. Let's see. Hey, White Conf Phil. Yep. And my laptop was not set up for it at all. So that's why I'm an hour late. Okay, today is Tuesday, the 2nd of October, 2018. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day, except for like the last week and a half. And I stream it live on Twitch, Monday through Friday. I continue to work on Basecode, which is my programming language, my little baby. Let's see, last week, so I streamed Monday, Tuesday, I was out Wednesday through Friday traveling. But I did get a chance to work on quite a bit of stuff on the compiler. And one of the big things I did was some house cleaning and some refactoring. And I was pretty happy with all that. Hold on one sec here. This is going to look horrible because I only have one monitor. Yeah, this is a little loud. Okay. So, what have I done? So first, I renamed the library. It was Alpha Core. I renamed it to Basecode because that's really, the compiler is the shared library, and the command line is just a little bootstrapper that calls it. And in addition to that, I created a public include now, so external programs that link against this shared library, they just have to pound include Basecode compiler, and they're all set. Then in the VM part of the shared library, I did a bunch of cleanup. A lot of this was just leading up toward refactoring how variables worked in the compiler and the assembler a little bit, but also the interpreter. So one of the patterns I typically follow with C or C++ is I'll have a forward declare header file, and I'll typically call it like types or, you know, whatever. In this case, I called it VM types. And I hadn't done this for the VM namespace. I'd done it for the compiler and the elements, but not this. So I forward declare classes and type defs. And so I took all, generally what I put in these headers are enums, enum classes, conversion functions, lookup functions. If I have mapping tables and things, they go in here. And a bunch of constants. So everything that was in that terp header file, but not exclusively that, it was in, there's stuff that came from other header files here too. That has moved into that forward declare file. One exception was the instruction cache for the interpreter. The only thing that uses the instruction cache is the interpreter. So I just left that there. The other thing I did, so the interpreter had the FFI implementation inside it. It had the heap allocator inside it. And those really are kind of, in my opinion, pluggable pieces, things that you might want to swap. So like the default heap allocator for the interpreter right now is, it's just a simple binary tree that keeps track of the blocks that get allocated, and when you free blocks, it tries to coalesce them. It's a very primitive and simplistic, allocator. But perhaps if you're using the interpreter and you have a different kind of allocator or more advanced allocator, you can pass in an implementation of that interface now, and it'll use that to do whatever you need it to do. Same thing with the FFI. The interpreter needs a way to invoke FFI stuff, but it really shouldn't own that. And the interface is pretty clean in terms of what you would expect for, we call reset, we set a calling convention, we, let's see, what do? We push an argument, we call, so it's a wrapper around that concept. I happen to be using dyn call as the implementation mechanism for that, but you could build a different FFI mechanism and pass the pointer in to that interface and you'd be good to go. So I did that stuff, and that took a lot of, again, like orthogonal concerns out of terp and really just boiled it down to what it needs to be, right? It has its register file, it has a pointer to a function for an interface provider, to an allocator, and that's it, right? It's much, much simpler than it was. So then that gave us an FFI class, and things that were on the interpreter are now here. So the hold on one sec here. Clearing the FFI, resetting it, registering a function, initializing, call, loading shared libraries, all that stuff moved into here. This stuff used to live on terp, now it just lives here. And I just nice and cleanly separates out this part from the core interpreter. Then for allocation, I took my really simple heap block allocator implementation. I created there's an interface that is in VM types now. And this is it. You can reset it, you can initialize it, alloc size free. That's what the API is for that. And then the default allocator is just the version I had baked into the interpreter, which, like I say, it's just a really simple, it's a linked list, but you can also view it kind of as a binary tree, and it'll try to, reuse blocks if it can. It'll split them, it'll coalesce them, but implementation wise, it's not that complicated. It's 188 lines. So, but that moved out, that got cleaned up a lot. And then, let's see, well, tons of header file cleanup, which helps build times a little, not significantly, but a little. I don't think I changed anything too significant on assembler. So yeah, that all got cleaned up. And then in the compiler, I beefed up the compiler types for declaration. This was kind of lacking compared to some other stuff, so I made it much more consistent. But I added this new variable handle T, which we'll talk about here. I also completely redid string interning. So we have a string intern map now. This used to be on the this used to be on the scope manager. And so this is a completely separate thing now. And the way that program handles string interning is much more logical. And so we now have just like everything else we do at the top level of the compiler, we have a intern string literals. So this gets our string literals. We loop over them and we add them to that string intern map. So session now has a string intern map on it. And so that's accessible, to everything essentially in the tool chain and the plumbing within the compiler, if things need to access it. And when we were not grouping, but emit section variable, so we used to have code in here, right, that was doing stuff for string interning. That's all gone. So we don't special case strings there at all. So that simplified a bunch of stuff. And yeah, and then in element builder, string, I think it was make string. This used to be much more complex, right? This used to be, they would grab, this is why we had it on the scope manager. This used to grab the old map for intern strings and it would do stuff. Not necessary. That was prior to the refactoring for program to be kind of the top level control for everything. So now we just make an element like we always do. And then we call that, intern string thing on program, and it builds our intern string array. And then on session, we have emit interned strings, because this guy owns that collection. And then if we go to string intern map, he has an emit on him. And yeah, he's a he. So pretty simple, right? We make a basic block, we put a comment, we put it in the only section. We loop over the intern strings, we align them, we put a comment, and then we use our new enhanced string emit on the instruction block, passing in the base label. So that's the very beginning of the intern string or string literal structure, and then a label for where the data itself lives. There used to be a method, and there's still a proxy now on string literal that would give us an escape value. And I moved that to just a global function in common because now a couple places are using it. So string literal just calls that. And of course, nothing's calling this, so we could probably just get rid of that. But yeah, we escape it so we can encode it properly. And then there's a couple of helper functions on string intern map. So for a given intern string ID, we can create the strings that are the labels. And this is really convenient because then anywhere in the compiler toolchain, we can get to the intern map through the session. We can say, hey, give me the base label for this string, give me the data label for this string, and it gives you the right label. So that's really convenient. So then if we just look at what that does now, right, so do I have any string? I do, I think. Types. Here we go. So now we have this intern string literal section, and we dump out these structures with the two labels. So that's perfect. And that's apart from any variables that get created. Okay. So let's, what else? There are tons of little bug fixes and things. Yeah, so then let's talk about variables. Because this was kind of a big thing that big refactoring I was starting. And so what we have now is an unordered map of compiler variable. I called this assembly variable to start, but then I just renamed it to variable because it seemed redundant. So variable has flags on it. So it can be addressed, read, written, copied, activated. You can create a variable by passing in a session reference and an element. So this is a key difference from what I had before. Now you can pass in any element in the compiler DOM. If it's something that is an actual variable, then you get an actual, register configuration that points at that variable. If it's just an element that's temporary and it just needs a register, then you'll just get a temporary register. Very important, now there are accessors for getting fields of a particular variable. So if the type of this variable is a composite type, then you can access a field on that composite type. And you can do it by element. So this would be, yeah, hey Magnum Baguette. So this would be like an identifier reference or whatever, or internally, if we want to hard code the name, we can do that. And there are some places in the code where I do that. So we can read it, write it. These are implicit, and I'm not 100% sure I'm going to keep these. but the implication here is if we have a target register, right, this involves that. You can address it, right? So addressing it, hey, FD God 92. So this will load the address of that variable in memory, activating it. So this is really an active variable is something that's consuming registers out of the register pool. If it's not active, it isn't using any registers at that point. And this is where that variable handle T comes in. So we'll talk about that later. Hey, thanks for the subscription. I appreciate it. Variables can have parents. So if you have a variable that's a composite, you get a field. That field has a parent to the parent variable. It also has a field pointer to it as well, which is important for being able to go down the chain. We can check whether or not a variable is activated. We can write to it. So we can write a literal integer value right now. Eventually I'll have to add float and double in here. We can write another variable to a variable. This is a much nicer abstraction than what I had before. We can get the pointer to the element that gets passed in when this is created. And then we can get const references to the value and address register for this variable. Internally, we have a flag, read and set, and then this variable has a variable register T, a pointer to a parent, a reference to its session, a address register, a type, which is, this is really critical too, because while I had type on the old implementation, it was not being really used properly. And field, so if this variable is a child of something else, we have a field in the model, so we have a pointer to that. And that's important again because field has the offset of where that lives within that structure, the pointer to the element, and the flags. So then, and then this is just some commented stuff of what I had before, which I don't even really need to keep anymore. Variable register T, I changed it a little bit. Really, this is just a wrapper around allocating and deallocating registers from the assembler. But I think I can actually refactor this on the assembler side so that it's more or less transparent. And so let's take a look then at an example of how this gets used, because it's much better than what I had before. So this is the binary operator for assignment now. So if we were to look at this in prior versions, it was like 30 or 40 lines of code, and now it's 8. And you know, some of that's just returns because of whether or not it succeeded or not. So there's this variable handle T struct. So what I did was on element, I used to, hey, Cyanox, on element, I used to have 2 different ways of getting to a compiler variable, which was just stupid. And so I moved all that to session, and I'm streaming from my laptop, so I don't have multiple monitors. I'm also streaming at a much lower bit rate, so hopefully it's not shit. Anyway, so session has that map of variables, and good. I'm glad it looks good. So, but we get a pointer back essentially to the variable that we're dealing with. And there, we want to activate and we want to deactivate. And, you know, very C++ism, I wanted to use RAII here so that I could wrap it in something that was a stack thing, that an auto that would, you know, automatically destruct when we reach the end of that scope. And so that's what this is. So on session, we have a variable accessor. This looks at the type of the incoming element, does a little bit of manipulation in some cases. Then we look in our map, hey, do we have this variable? If not, we're going to make a new one. We're going to put it in the map, and we're going to create a new handle, or we're going to set the pointer on the handle. So this handle kind of almost works in a similar way, very primitive, but very similar way to like the unique putter. It overrides the operator arrow, and then that stack auto thing behaves like a pointer. I can use this like a pointer now. It's wrapped in that struct. And then when this guy falls out of scope here, it's going to deactivate that variable, and those registers are going to be freed in the register allocator on the assembler. But really now I can get the left-hand side variable and get the right-hand side variable, and I can write the left, you know, write the right to the left. There's English for you. So much simpler than what was here before. Much more consistent. So, and then of course I went through everywhere where I was doing stuff like this, and you know, so here we get the left-hand side, we read it. Here we get the right-hand side, we read it. Now there's like a second pass here that I haven't done yet, and that is, you know, temporary. So there, I have this concept of a target register, and then there's cases where we need special temporary registers from the assembler. Those are still working the way they've always worked, but yeah, if we go to like argument list here, oops, I'm using I bring my DOS keyboard with me when I travel, and it's a nice keyboard, but it's laid out slightly differently. So then my muscle memory is off. Yeah, so this is so much simpler than what I had here before. You know, we just take the arg element from the argument list, we get a variable for it, we read it, we push it, you know, piece of cake. So it really cleaned up everything. And then what that allowed me to do was implement member access. So this is where, do I have, what was it called? Compiler. I can't remember what I called it. So I added a new test program, compiler variables. That's right. So, so actually, yeah, let's look at some stuff here. So some stuff. Oh, so on the test program side, I started refactoring those and making them more serious, I guess you could say. So what I did was I created a support folder. I added a module file. So the foreign function declaration is here now. I have an internal assert that's actually written in Basecode. So that's kind of cool. And now I'm including that with a module reference, and then we're accessing things through that support module. So I was able to get this code to work properly. So I can create a string, it initializes it, then we'll look at that code that gets generated. I can access the fields, length, capacity, data. I can get the pointer, put it in a different pointer, and then that is correct. I can loop over the characters and dereference them and print them out. So that's working. So let's run that. That is deref. That's a pointer. So on the left, that means pointer to. On the right, that means pointer from or dereference. That's a Pascal syntax for pointers. Yeah, my laptop's getting a workout here. Yeah, so yesterday I just wasn't paying attention, and I always forget where the central time zone and eastern time zone line is in Indiana, and I had crossed it, hadn't even paid attention. So when I looked at the clock, I'm like, oh shit, I need to like hop online because it's time. But no, I was an hour ahead because I crossed over time zones, not realizing it. So that's why I was early yesterday. And then yesterday, because I did that thing in the car, I realized I have a cell phone mount, but it was one of those, it mounts to your vent, uh, which it's just not up high enough for what I wanted to do. So I got another mount and it's up on the dash now. So yeah, next time I won't have to hold the phone, which will be nice. Okay, let's look at some code. So this is the FizzBuzz program. Oh no, I wanted to change it so it ran the right one. Compiler variables. Okay, so what do we got here? So you'll see that text length is 12. So that's what we got here. Capacity is 32 because that's the default capacity for a string. The data, we see the pointer value, and then when we assign it to another variable, we get the same thing. So that's good. And then you'll see this hello world here, but that's not through printing the whole string. That's through pointer accessing in memory, right? So we copy the pointer into content. We print out the value of content as an address. We set I to 0. We loop over for the length of that string. Then we print out the characters, dereferencing them as we go. And that works. So that's good. So let's take a look at the code that gets generated for this. Um, okay, so we have a variable text, which is a string. A string is a composite type. So this is 16 bytes. Hey, Slayer Darth. We have a pointer, which is a quad word, and we have an index variable, which is 32-bit integer. So we get an initializer for that text variable because, again, there's two parts to strings. There's going to be two parts to arrays. You have the literal that goes into a pool or an interned grouping in memory. Then you have the actual structure, and that's because I'm on a laptop. I'm in a hotel. So what was I saying? Right. So the actual structure has to be initialized, and we have to actually copy that string literal into the allocated memory for that structure. So the very first thing we do is we get the address of the text variable. We move the value of 12 into I3 here. We store it. Now you'll notice, so this is storing it at the base address of that text structure. But the next one is 4 bytes offset. So we load 32 and we store that at the next field in the structure. Then you'll see we allocate 32 bytes. We put the address in I7. Then we call fill. This is like memset. So we're setting zeros for 32 bytes at that address. And then we get the address of the string literal and we copy it. So this is like mem copy. And this is the address we allocated on the heap. This is the address of where we're reading from. We're going to do 12 bytes. Then we're going to store at offset 8. So that if we look at a string structure, it's 4 bytes length, 4 bytes capacity, 8 bytes pointer for the data. So at offset 8 is the pointer to the data, which is what we allocated here. We store that pointer at that offset. So with the new variable implementation, this works perfectly. And I'll show you the code and string type that does that. And then when we come down here, so we get the address of text, we're going to then load the, so we get the address of text. Okay, so that's the address of the pointer in, I'm sorry, let me restate that. That's the address of the variable itself in the heap, but this is a struct. So we have to, or I'm sorry, I'm ahead of myself. I got to do that down below. This is the print statement prior to that. I was thinking we were in the while loop. So this, we're going to load the length field and we do the print. So then we get the address of text. Now we're going to load capacity. So oh, that's why I'm confused. This is redundant. We don't need that. Yeah. Okay, so I gotta fix that. This shouldn't be there. It's not harming anything, but it's a waste. This is the important one, right? We're gonna load the value of the capacity field into I5. So, and that's at offset 4. And then we push that, we call print. This is the data field. Here's where we assign the pointer to the content variable. So we get the address of text, we load the value of the data field, and we store it in the content variable. So here's the while loop. We get the address of the I variable. We Yeah, we load it. Then we're going to get the length field. So we get the address of text, we load the length field, and then we do our comparison, and then this is the branch. Now, here's an example of something that eventually, probably when I rewrite it for self-hosting, this is an area where we'll want to optimize, right? Because we can look in the body and we can see, hey, is this field and this predicate modified? If it isn't, hoist that out once to get that value and hold it, in a temp register that's persistent for the whole loop, so we don't have to keep reaccessing memory. So then in the body of the loop, we get okay, so this is what I was trying to explain earlier, and I was ahead of myself. So content is an 8-byte integer that's sitting in the heap. We're going to get the address to where those 8 bytes are sitting. So that's this. Then we're going to load the 8 bytes into I2. So, but that's another address. So then this is where the pointer dereference comes in, right? We take that address and load the value based on the size of the pointer into a value register. And then that's I1 is the byte that's pointing, that pointer is pointing to at that point. Yeah, that's really confusing. We print that out and we do some incrementing and we loop. And then for finalizing, we get the address of text because we allocated memory for that string. And at least the way I'm doing this now on the interpreter side, and this is very much, I think, going to evolve, but I'm freeing the memory in the interpreter heap explicitly at the end. I mean, technically, again, we could make the argument that the interpreter owns that memory ultimately. So, I don't have to explicitly free it. But then again, the bytecode is the guide for ultimate native code generation. So, yeah. So one thing I noticed as I was going through this, this is not a family vacation. So I did notice something that was kind of broke. Yeah. So here, when we generate code for this, we're generating an extra load that we don't need. And yeah. Hey, Lori Master. Yep, I am currently in Cincinnati, Ohio. So I've been to Denver and I've been to Chicago and now Cincinnati. Oh, this is new. I closed the other one. No. No. So I got to tell you guys a story of my near death as I was crossing from Colorado into Nebraska. Um, so there's an interstate that goes kind of northeast-ish. It's called 76, and it takes you from Denver to I-80, and I-80 roughly runs east to west across the U.S. And so I-76 is one of those interstates that just terminates, and it just merges into I-80 as you're going east. So we have a road sign. Let's see, U.S. road sign merge new lane. I don't even know what the official sign name is. Okay, so this means that the lane that you are in, you are merging into an existing lane. And this means you need to be careful. Yeah, it's called the added lane. So this is a sign that says you're merging in with traffic, but the lane you're in stays. It doesn't go away. And the people who are there, they stay in their lane. Okay, this is the sign that is present as you are merging on 76 heading east into I-80 heading east. Now, here's what happened. A truck driver misread this sign. He thought he saw this. And he didn't see me in my little teeny tiny car. And he just merged right into me. He didn't actually hit me because, hey, technology, my car's, side of, collision avoidance went off, which gave me enough time to pull into the very rough grass median between the two sides of the interstate. And, he recognized he'd done bad, so he pulled over, and there was poor him, for the truck driver, there was a cop. Of course, it's a good spot for them to sit, but there was a cop trying to catch people speeding, so immediately he came over, and that truck driver unfortunately had to pay a really big fine because he was driving off hours, his logbook wasn't right, and then he ran me off the road. So yeah, that was interesting. So I have to say, hurrah for, technology. Because if that hadn't have gone off, he would have hit me. I wouldn't have noticed it in time. Now I will say this: I thought my car was busted anyway because the road, well, it's not even road. The median in the center is just undeveloped. Land. There's grass and rocks and shit there. And it was rough. Thankfully, I was able to come to a stop pretty quickly, but yeah, that was interesting. Well, this guy, and again, I really feel sorry for these truck drivers. I mean, I'm sure the guy had been driving for like 24 hours without sleep. He seemed really out of it, and yeah. Yeah, I drive, especially if I have to make multiple stops. Um, I flying in the well, domestic flying in the United States has just really become a very unpleasant experience for me. Um, and there's a variety of reasons for it. Um, but primarily it's just the security circus that you have to go through now at the airport. And I have to carry medications. Some of those medications are liquid. Even though everything conforms to TSA guidelines, you have agents that are very poorly traveled or very poorly trained, and they see stuff that they don't see very often. They flip out, um, and then I miss flights. You know, it's just not really super pleasant experience. And it's like if there was one airport that was particularly a problem, but the others weren't, and I would say okay, no big deal. But if I have to like fly, say 8 times to make a full circuit, I mean that's 8 encounters with TSA that is it. I mean, I'll take a trucker running me off the road, quite honestly. Um, it's yeah, it's just a really unpleasant experience. And even though you get tired driving and it's boring. Um, I always like I can pull over anytime I want. You know, um, if I'm hungry, I can eat. If I need to walk around for an hour, I can get out and walk around. Try to do that on a plane. Um, and then as long as, I don't do anything super insane on the roadway, I'm my chances of going to jail or being detained for long periods of time by authorities is very low. Um, but if I fly, uh, again, because I seem to set off all of TSA's bells and whistles and alarms, my chances of having an encounter where I'm going to end up in a cell just feels much, much higher to me. And yeah, so it's just not worth the risk. This isn't a new house. This is a hotel. Um, yeah, truck drivers are, yeah, they're very poorly treated. There's very crazy expectations. Mm. This is my cell phone, so I am using it as a hotspot right now. The wireless in this hotel is shit, so there's absolutely no way I'd have been able to stream on it. Um, no, I'm actually pretty happy today. I'm a little tired, but yeah. So this load here in this context is superfluous because, and I know why it's happening. The reason it's happening. So if we go to variable. All right, I'm not. I don't need this stuff. So read. So here's the challenge. If we have a parent, we need to get the parent's value. But okay, so if the parent is a pointer, we want to do the extra load because we need to get the value of that so that the child, yeah, I think that's what I want. Otherwise, in the case of a child saying to its parent, hey, access yourself if you haven't, or read, if you haven't, then what we really want to do is we want to address it. Because we don't want to load the value for the parent. We don't need to do that in this case. Because it's always going to be a composite type. Now pointers are a little bit, they're a little bit different. Would it ever be the case that the parent, I'm not sure. Okay, so it still runs, and let's see what code we got here. I'm guessing it dropped the extra read, or extra load. Yes, good. So we get the address text, we load the value, we get the address text, we load the value. So we're not getting that extra read in there, the extra load, because we don't need it in that case. However, I'm just thinking here. No, yeah, we need that, because you could have a pointer to a composite type. Yeah, so I'm going to leave that. I think that's correct in this case. Okay, so that fixes that problem. There's another problem, and it was related to type inference. And I remember it, but I didn't fix it. This becomes, I think it becomes a pointer to a pointer. So we need to fix that. And I think it's really just more the name, maybe. Yeah, see? You have pointer to a pointer to way. But it's, yeah, I don't know why it's doing that. So let's figure that out. Fix the bugs. Fix the bugs. Oh yeah, there were a couple bugs in here. I needed to explicitly handle the else here and check for errors. And there was one other bug that I fixed here. Okay, so let's see what our type inference is doing here. I think it's just passing the wrong name when it makes the type reference. Okay, so what symbol is this for? Oh, this is for print. I don't give a shit about print. Not a super. Not super. Text. No. Content. Yes. Okay, so we're in binary operator, which makes sense. This is in member access. So yeah, we're going to take the yeah, that's not right. That's not going to work. Because the right-hand side is just going to be an identifier. Yeah. Okay. Well, but that's weird though, because, all right, what is... Okay, so we're going to, yeah, all right. Oh, sorry, Magnum Baguette. I'm using my iPad to track chat, and so I have to look to my left to see it. I'm not exactly sure. My best guess right now is sometime next week. Probably mid next week, roughly speaking. I'm not 100% sure. What you're saying is that my mobile streaming sucks. It's not as good as my home stream. Yeah. Okay, so this is actually not wrong, but what is it doing? So the reference is type result. Oh, this is already. Why is that happening? We've got a reference and a reference. No, I guess that's right. No, I guess that's right, yeah. But what's the symbol on this? Okay. And then what's the symbol on this one? Yeah, so this one's already a pointer to a U8 because that's what it is. Okay, so then it's probably in the code that's formatting it. Let's see, where do I want to look? Hmm. Where's the extra care coming from? Somebody keeps texting me. All right, I'm gonna have to wrap this up. I hate AT&T. You know, ugh. All right, so I'm gonna track down why that type isn't working correctly, or I should say, why that name is not coming out correctly. It's probably something really small. And then the next thing I'm going to do is to sort of kind of like give an idea of what's next. I don't know why I can't remember the name of this. So this works. This works too, except this doesn't. And the reason is really just because what I need to do is in that variable function in session, I need to add a case here where I'm handling the member access. So if the element that I pass in here is a member access binary operator, I need to resolve that identifier reference here and return the variable for the right hand side. And then what that's going to do is recursively, that's going to allow this. So here, when we say give me a variable for the left hand side, if that's a nested binary operator, which is a member access, we need to resolve that at that point. So the variable that comes back here is the right hand side of that. So essentially we need to recursively resolve member accesses at that point. Then the rest of this works fine. So I need to do that, and that should fix this. Then I'm going to need to test assignment to the member access on the left hand side and resolve any issues there. And then at that point, like, member access pointer dereferencing should be good. Then I need to start working on array subscripting and all that. Then we're in a really good position to finalize type systems and get to more interesting stuff. So I'm going to wrap it here because I needed to call AT&T and argue with them about bandwidth. And it's so silly. You know, I have been an AT&T customer, which is probably my own fault, for decades, really. I mean, I've used Sprint, I've used T-Mobile, I've used Verizon. I just have always had issues with those. But The thing about AT&T that really pisses me off is they go back and forth between this, you have to pay for everything. No, we're going to give you unlimited. And you know, when I upgraded my family's phones, and it really wasn't much of an upgrade. I just went, like we all had iPhone 6s and we went to 7. At the time, I was on this plan where I was paying for lots of bandwidth every month. And I was fine with that because I knew exactly how much I was buying, I knew how much we used, and it was never an issue. Then they're like, oh, well, we have this unlimited thing again, and you'll just automatically be enrolled in that. I'm like, okay, but is it really unlimited? Of course it's not, right? And then, you end up right back where you started. So anyway, my little rant on cell phone providers. Anyhow, okay, guys, I will be online tomorrow now that I've got my laptop set up for streaming. I should be online roughly on time tomorrow morning, and I'll probably stream for an hour to two tomorrow. Thursday and Friday, I'm thinking are probably going to. It's a 50-50 shot that I might be streaming on those days this week. I'll let you know tomorrow for sure. And then most likely I'll stream again when I get home. So I'll try to update the calendar and keep you guys posted on that. But so let's see here. UNF4 Mil4R. Hey Jeff, I have a question for your CCONG implementation. For example, in window H, do you write struct SDL window on top? So yes, that was, so just so you know, on the CCONG stuff, and of course this was just before I had to do stuff for work. I'm planning on doing more videos to finish that up. And I had gone through and vendored all the dependencies for CCONG. So now you should just be able to pull that repository down, build it, and it should run. And to answer your question, yes, I did some type defs because I was trying to forward declare, so I didn't need to include some things in some places. So hopefully that answers that question. And when I get back onto a normal schedule again, I will definitely be doing more CCONG videos, and I'm going to get back to the Rust mystery text adventure game. I've spent a lot of time thinking about what I'm going to do for the text parser and all that, so I should be able to get back to that as well. Okay, guys, have a good one. I appreciate everybody dropping by, and I will be online tomorrow morning. And then Thursday, Friday, it's kind of iffy, and I'll let you know what the schedule is going to look like after that. Yeah, that's true. I probably, because I implemented a lot of stuff. That's one of my, I get excited about stuff, so then I write a bunch of code. So, all right. Ooh, look at that. I'll see you guys tomorrow. Have a good one.